In this video, I'll be talking about loop in transportation problem. But before we go to the formal definition of a loop, let me come to very three basic question. Why loop comes in the transportation problem, or what are the situation in which we'll be talking about the loop in the transportation problem? Because in my last video, we have found the optimal solution of a transportation problem using UV method. And we have obtained the net evaluation, that is Zij minus Cij is all less than or equal to 0 with the dual variable, and that is what we have talked about UV method. So in which situation we will be talking about loop? So that's the first question. And once we know in which situation we'll be talking about the loop, then what is the definition of the loop? What is the formal definition of the loop? And third thing we need to learn in this video is how to draw the loop and how to conclude or reason further about the optimal solution, or how does it contribute in the optimal solution. In my previous video, we have discussed this example, find the optimal solution of the transportation problem and find the initial BFS using VAM. So we have solved this question complete in the last video, and you can see here that we have applied Vogel's approximation method here to find initial BFS. This is initial BFS, and then here I have calculated Zij minus Cij. And this is what I have applied here, UV method. This is what is also known as UV method. So U and V stands for the dual variable. You can watch my previous video on dual variables. So once we have applied UV method, we know that for basic variable ui plus vj is equal to Cij. So we calculate these ui vj values here. And we see that for non-basic variable ui plus vj minus Cij, which is Zij minus Cij, this all the quantity turns out to be negative. So here all the quantity turns out to be negative. So this means the current solution is optimal. And so here I have to put now a remark. So suppose in some question, in some problem, after applying UV method, we are calculating Zij minus Cij, and this turns out to be positive for at least one variable. So if it is positive and my objective function is minimization, because we are solving a minimization transportation problem, objective function of transportation problem is minimization. So this means that the current transportation problem is not optimal, because for optimal solution, Zij minus Cij should be less than or equal to 0. For optimal solution, we have this condition, Zij minus Cij should be less than or equal to 0. And if this condition is violated, that means usually, as we have applied in the simplex method, if we want to recall here the simplex method, if my Zij minus Cij is not positive and this problem is minimization, so we enter most positive, and then accordingly we will leave one variable. So now this process is kind of called as looping here. So a similar process in transportation problem is called loop, where we have an entering variable, and corresponding to that entering variable, we are going to find which variable will be going to leave the basis. Let's see the formal definition of the loop is, in a transportation problem, or we may say the transportation table, an ordered set of 4 or more cells is said to form a loop. So minimum in a loop we must have 4 cells. And loop has the normal definition. Loop means that it has to be a kind of a closed thing, not an open. Any two adjacent cell in the ordered set lie in the same row or the same column. So in same row or same column, at least there has to be 2. And then any 3 or more adjacent cell in that ordered set do not lie in the same row or same cell, although loop can involve any number of cells. So for example, if I just understand the situation from an example, so consider a loop. These are, now what I have written here, these are the positions of the cell. These are positions in transportation table. So if I want to draw these in the transportation table, what will it look like? Any transportation table. So this is a transportation problem. And here if I want to look it as 3, 2. So which position is 3, 2? So this is third row and second one. So that is this one, third row and second. And then I have 2, 2, which means it is this. Then I have 2, 3, which means it is this. Then I have 1, 3, which means it is this. Then I have 1, 5. So we have first row, fifth column, which is this. And then we have 3, 5, which is this. We started, now you see, we started from this particular cell. We started from here. And then we have moved to this cell. Then we have moved to this cell. And then this cell, then this cell, then this cell. And we come back to this cell. So this is what it says, that the last cell is followed by the first cell. So here we have already written the first cell is then followed by the last cell. So it has to be something related to closed. It's not necessary any particular shape. You may have shapes are really not important here. But in a row and in a column, in every row and in every column, you see here in every row or in every column, wherever this loop has come, it has only 2 cells, and the total number of cells in a loop are always even. Total number of cells in a loop are even. Now let me to take a proper example in the transportation problem. Now let's solve this particular transportation problem using UV method, and we use here northwest method to find the initial BFS. Now this is essentially the same problem that we have already considered in my last video, and even in this video that I have shown previously, where I have found the initial BFS using Vogel's approximation method. And what is the supply given to here is 13, 19, 16, 7 unit, 14 unit, 21 unit, 6 unit. So these were 3 supplies, and we have 4 destinations. And before we apply any method, I wanted to make sure that this problem is balanced. So this is a balanced problem. We can see the sum of availability and the sum of the demand, it is same. So it's not an unbalanced problem. If it is unbalanced problem, we always need to make sure that it is a balanced problem. Now, once I find the solution of this problem for initial BFS using north-west method, so minimum of 7 and 13 will go here. So 7 unit will go here. And that means this particular is exhausted, and here I am left with the quantity 6. And then I move to the next cell. So when I move to the next cell, this means I get a 6 here. So this means this whole is exhausted, row is exhausted. And here we are left with 8. And then we move down, and this means here I am contributing 8. And then we are left here this quantity as 11. And then we'll move to the next cell. So this is minimum of 11. And this means this is exhausted, and here we are left with a quantity 10. And then the last row will let me know that 10 unit goes here, and we have an allocation of 6 unit. So we got initial BFS here, and at initial BFS when I calculate the Z at northwest method. Okay, so this is initial. So we cannot say it is optimal unless until we have not applied the UV method. So Z at initial, when we calculate, this will give me a quantity by cost and the allocation, and then I'm going to sum 56 into 6 plus 35 into 8 plus 21 into 11 plus 71 into 10 plus 63 into 6, and this quantity is 1913. But we have seen in the same question through the Vogel's approximation method that the optimal solution comes at 1235. So here you can see at the first stage that the Z is 1913. So when I'm going to apply UV, so sum of the Zij minus Cij should be positive. Now let's put the allocation again here, and let us calculate the UV. So the allocation here is 7, 6, 8, 11, 10, and we have 6. And now I want to apply UI Vj. So when I want to apply UI Vj, either you can write separately, or maybe you can write here in the table itself on the right aligned or the left aligned. So V2, V3, V4. Now because this is a basic variable, so we have already know that for basic variable, Ui plus Vj should be equal to Cij. So this is true for the basic variable always, and one of the basic variable of the dual one of the dual variable can take any arbitrary value. So let me to assign any arbitrary value here. Let me to take u1 equal to 0. So if I take u1 equal to 0, so from the first cell, when I'll take u1 plus v1 should be equal to the cost 14. So v1 is 14, and then once I know it is 0, and then using this 52, I know v2 is 56. If this quantity is 56, so I know how to calculate the other quantities. This u2 comes out to be minus 21. If this is minus 21, my v3 comes out to be 42. And if it is 42, u3 comes out to be plus 29. And v4 will come out to be 34. Okay, so either you calculate in the table itself, or if it's not clear, you may even write these equations for the basic variable. What is the equations for the basic variable was u1 plus v1 is equal to 14, and then I have u1 plus v2 equal to 56. Then I have u2 plus v2 equal to 35, and I also have u2 plus v3 that is equal to the cos 21. And then we have u3 plus v3 equal to 71, and the last was u3 plus v4 equal to 63. Remember to associate this with the cost, not with the allocation. The allocation xi. So these are the values for xi, which I have circled in the green color. These are only letting me know that these are basic variables or for basic cells. So from here only I am going to write these equations, and I have considered here put u1 equal to 0. So we have calculated other vi. Now for the non-basic variable, I want to calculate the values for non-basic variable. Now for non-basic variable, we see which are the non-basic variables that are highlighted probably with some color. Let me to highlight with some yellow color. So non-basic cells are, these are the non-basic cells. Okay, so non-basic cells, yellow color, where there is no allocation. And if I look at these cells, so what I need to check is I need to calculate now zij. So I need to calculate z, what would be the first position of first cell, first non-basic cell. So this is first row, third destination center. So this is C13. This means it is u1 plus v3 minus C13. In my last video, we have already seen that Zij, this is equal to ui plus vj, and this is what we are using throughout in this calculation. So this quantity we need to calculate, and what would be this quantity here? This quantity is minus 6. And how this quantity is? So you can see u1 is 0. What is v3? v3 is 42, and then we have C13. C13 is minus 48, so this quantity is minus 6. Okay. In the similar way, we calculate Z14 minus C14, which means it is U1 plus V4 minus C14. And this quantity, once we know U1, V2, we have already calculated UIs and we have already calculated VIs. So U1 is 0, V4 we know 34. So and C14 is 27. So once I calculate this quantity C14, this comes out to be 7. And then we calculate Z21 minus C21. This quantity comes out to be minus 89. And then we calculate Z24 minus C24. This quantity comes out to be minus 68. Similarly, we calculate Z31 minus C31 and Z32 minus C32. Now we need to look at here. So look here. Zij minus Cij is not less than or equal to 0 for every I and j for non-basic variable. But this was the criteria for the optimal solution. If all of them are less than or equal to 0, then my current solution is optimal. But here they are not. So this means I need to find out an entering variable, and corresponding to that entering variable, I need to identify which would be a leaving variable. So we enter the variable with most positive and we can compare among the, now this is 7 is positive and then there is a quantity 54 is positive. So that means now from these two, now from here we compare Zij minus Cij values of non-basic variable which are most positive, which is most positive. So enter, so this is the first, again same criteria as we have applied in simplex method. Enter or loop starts from where Zij minus Cij is most positive. In case there are ties, then you can choose any. Once you know which is the entering variable, we can going to find the leaving variable also. So we have found entering variable. Let me to draw the now loop and then we'll find out the leaving variable. Now for looping, let me to draw this table again. This is that table, and now in that table, since we have identified the Zij which is most positive, and which was most positive, we can see from the calculation Z32 minus C32. This one is most positive. So this means Z32, this is the position which is most positive cell. So this was most positive cell. So we want to start loop from here. Start loop from this cell. Okay. Now if I want to start the loop from this cell, this means I am going to enter something. This particular position would be going to be my basic variable. And if this is going to be basic variable, I am supposed to allocate something here, and that I am going to draw now with the green cell in coming after the loops. So here let's put now a quantity theta. At this moment we do not know how much I have to allocate here. That we will calculate what is the value of this basic variable. Put a theta here and then identify a loop. Loop has to go through the basic cell. You have to make a basic cell. So you see here, either you can go here, this is the first position, or from here you can come back to this basic cell. From this you can come back to this basic cell and you can come back. So loop means that you start from here, you go to a basic cell, turn from a basic cell and then come back. So suppose if I had gone from theta through this 6 in the looping process, and then there is no cell on the right hand side here to 6, so I could have then come to 7, but then I have to make again a turn. There are no basic cells here. In the loop we have to move horizontally or vertically only, and in a row and in a column there has to be only 2 basic cells that we are going to use, including this cell that we have involved now as a theta. And now I'm going to remix. So now what is theta here? How much quantity do we need to allocate the theta? So which variable will theta will be? So now what is the value for theta? Theta is the minimum negative signed So now this is the loop, and in that loop where we have put theta, we assign a sign plus because we want to allocate something in this cell and we want to make this cell as a basic cell. Whatever we will allocate here, the same quantity will be subtracted from this cell. The same quantity will be added to this cell. The same quantity will be subtracted from here and back to addition. This is done, this addition subtraction process is done so that whatever quantity we add here, same is subtracted to satisfy the constraint of the transportation problem. Okay, we'll see in a minute how the constraints are satisfied. And what is the value for theta? Theta is the minimum of negative signed allocation values. What is the negative signed allocation values here now? Let's see. In that loop, wherever you got the negative we got at 2 places, at 8 and at 10. These are the 2 allocation which got the negative sign. So you need to choose the minimum among this. This is 8. So minimum is 8, And so my next allocation becomes, and those allocation which were not the part of loop, they remain as it is. So this means 7 remain as it is, 6 remain as it is. These were not the part of the loop, 6 remain as it is. What we have changed is these 4 location. At the very first, put theta is the quantity as 8. We have added here 8. Same quantity I have to subtract from this particular cell that I have now highlighted as yellow, because whatever is the quantity, or you may even say here minus theta. So we may say here minus theta, and then here you may say plus theta. Again this quantity is minus theta. So when I subtract this theta, 8 minus 8, it is 0. So that means now this cell becomes the non-basic cell. So maybe I can write here, this cell is now non-basic cell. This is now non-basic cell. So if this is non-basic cell and we continue calculating the other allocations, now 11 plus 8, so this becomes 19, because we have to add here. In the 10, I have to subtract, so this becomes 10 minus 8, this becomes 2. Now if I sum row wise, sum allocation row wise, so what we see here is, if I sum here, this is 7 plus 6, this is 13. This is what the supply was available. In the second row, I have 19. In the third row, I had the total supply as 16. In this demand, I have the first destination demand was 7. The second destination demand was 14. The third destination demand was 21, and this is 6. If we don't add and subtract the same quantity, the constraint will not be satisfied, which is the original problem. That summation of xi row wise should be equal to ai, and the summation of xij column wise should be equal to the corresponding demand. So this is what is called the basic looping, that and also this help us to identify which variable have added and which variable have removed. So I can maybe write here very clearly, and remove the cell which comes with zero allocation in loop, So that's how we have removed the cell. Now we have to again check this Zj minus Cj. I don't know at this stage whether this solution is optimal or not. So we have to again check the optimality condition. So let me write here, again check optimality condition at this initial BFS. Now this is also, it's not initial, at this BFS. Okay. So because this is the now BFS that we have obtained, so let's write that table again. Write this table and we check the optimality condition at this particular BFS that we have just obtained. So here is the table with the new allocation that I have made, and I want to calculate ui vj. So let us again calculate first u1, u2, u3, and then we calculate v1, v2, v3 in the similar process. So once I put again ui, let me now take in this case u3 equal to 0. Any one variable we can take either 0 or any other quantity. This is completely arbitrary choice, and for the calculation purpose only we consider this as 0. Once I take this 0 with the similar manner, because we know for basic variable, so we are applying the same rule that for basic variable ui plus vj equal to cij. So find out those one, and with those combination you find the remaining other variables. So u1 comes out to be 21, v1 comes out to be minus 11, v2 is 31, v3 is 71, and v4 is 63. Non-basic cell, and I am calculating net evaluation here, and I am writing now the net evaluation here in the same table. And what is the net evaluation for the non-basic variable? For non-basic variable, net evaluation, that is Zij minus Cij, which means it is Ui plus Vj minus Cij. This quantity I am calculating and I am writing with this color. So let's do that. We already know what is U1, we already know what is V3, and we know the cost of 48 also. So when we calculate this quantity comes out to be, the first quantity comes out to be 48. So, and the next quantity comes out to be 61. This quantity is minus 143. Next is minus 54. This is minus 68. And the last, this comes out to be minus 110. Most positive, again we still have a quantity which is most positive. So we can say still Zij minus Cij are not less than or equal to 0. Had they been less than or equal to 0 for every ij, this is optimal and we know how to find the value for z. But at this table, it is still not optimal. So we find a loop. So again, find loop. So for loop, identify most positive Zij minus Cij cell, and which in this case is 61. So I am going to put a theta here. So put a theta here, and every time you put a theta here, this is where you want to allocate. So this is here, we will always have a plus sign. So this is my start, we'll always start with a plus sign here because we want to allocate something here. I want this to become a basic cell. And then we need to identify which are the basic variable through which loop can make a turn. So we can see here this 6. This is, I can go, directions are immaterial. Either you start from the bottom or you start from this. The loop is going to be the same. So you have this 8 and then you can see this one. You can overlap some of the cells. It's like identifying which cells. So loop is like an ordered pair. So for example, I am writing the position of the loop cells. Loop cells are, the first loop cell I have constructed is this one. So this was 1, 4. And then my loop cell is this one. That is, I've come back to this direction. So you can take this as 1, 2. Then I've come back to the next one. This is 3, 2. And then I take to the cell 3, 4. And from there I come back to 4, come back to 1. Okay. So from here you can identify, this 2 which seems to be overlapped here, but this is not overlap. It is just that we are shifting from this cell to the next cell. So this is what is called the loop. Okay. Now again we find what is the value for theta here. What is the theta here in this case? Theta is the minimum of negative quantities again. So what are the negative quantities in this case? We have identified with a plus sign. So this is alternatively negative. Then this is plus, and in this case this is negative. Okay. Once we know this is plus, this is negative, so we can see which are the next allocation. And what is theta here? Let's see, this is a minimum of 6 and 6 because both the negative sign comes on 6 and 6. So theta is 6. We know what is theta. So theta is 6, and let's see, find out the next case. So in this case, the loops will start from here. I have to allocate 6 here. Now, when you subtract 6 from this case, this leaves a 0 here. And when I add in this 8, this will leave a 14. And this 6 also leaves a 0. But one of the basic cell we have to vacate. We have to show this as a non-basic cell. So either you leave this or you leave this one as a non-basic cell. So I leave this as the I consider this as the non-basic cell. So this as the non-basic basic cell. You could have considered the other one also as a non-basic cell, and we have here a allocation of 0. And now the remaining allocations we are going to write. This is 19, this was 2, and we had a 7 allocation here. Again, we must always need to make sure that the constraints are satisfied. You can sum row wise and you can sum column wise to make sure that you have not left addition or subtraction while doing the looping. Now in this case, when I calculate UIVJ, so you need to again check the UIVJ for this case also, and we cannot directly conclude that this is the optimal solution. So let's calculate again Zij minus Cij for this case. So we have the allocation 7, 0, 6, 19, 14, 2. So let's calculate again the net evaluation for this particular table, and let me to write quickly the cost: 14, 56, 48, 27, 82, 35, 21, 81, 99, 31, 71, 63. So now let's calculate again the net evaluation for this particular table, and let's assign U1, U2, U3, V1, V2, V3 and V4. So once you calculate the net evaluation here, suppose if U1 is 0, then in that case what would be my V1? V1 is 14. So let's calculate quickly. V1 as 14. So in this case, if U1 is 0, V1 is 14. If U1 is 0, V2 is 56. And if V2 is 56, we can calculate U3. U3 is minus 25, and continue like this. We can find all other values. So this quantity is 96 and this quantity is 27. So we calculate now the non-basic cells net evaluation, which I am doing now here. So let's calculate the non-basic net evaluation that I am writing here. And these quantities are come out to be some still quantities as 96 minus 48. This is still positive. At this stage it is minus 143. At this stage this is minus 56. This quantity is minus 129. This quantity is minus 108. Here this is minus 67. So you may calculate either in the table or you can write the calculations separately if you don't want to write in the table. Otherwise we can write the calculations in the table itself. But now still see that there is a positive quantity here. Still this is the cell where theta should be the coming. This is going to be the entering variable. So this becomes the entering variable, and then we want to find the leaving variable. So let's again identify which is the basic cell from where we can come back the loop. We can see here there is a 2 here. That's one I can see as a basic variable. Then I can move to this cell, and then we can come back to this cell, and we can come back. And because we have started from here, so this is plus, so there is a negative here. Then we have a plus sign here, and we have a negative here. Once we allocate this negative, so is minimum of negative signed allocation. So what is minimum negative signed allocation? This is minimum of 0 and 2. So theta is 0. This means the location of 0, the cell containing 0 will change. This means here it is like a basic variable. So here a basic variable is taking the value 0, So this means this is nothing but it is a degenerate basic feasible solution that we are talking about from the last table. And then let's write now quickly the table. So the 0 location will shift to theta vector, that is in the first row, third column. So 0 will come here, this 2 will remain this one, and this 14 will remain this. Now this cell will become non-basic cell. So this will become non-basic cell. So this is what we have vacated, and remaining cell remain as it is. The 6 remain as it is, 19 remain as it is. And now in this last case, we again calculate ui vj, and we see that all of these quantity comes out to be negative. So if all of these are negative, I'm just writing, you can check the calculations. So these are all negative. So this means this current table is optimal, and we multiply z with a corresponding allocation. So 7 into this plus 0 into 48 plus 6 into 27 plus 19 into 2 plus 14 into 31 plus 2 into 7. And now we multiply allocation with the cost, and this gives you the answer 1235. So that's all about the looping. But it is entering and leaving criteria in the transportation problem. We call it as a loop because we want to, whatever we want to add, we want to subtract, and from where we have started, we want to come back to the same position so that the constraint of the transportation problem remains satisfied.